In this video, we'll be going over how to calculate the partial pressure of gas by using Dalton's law of partial pressure. Let's jump straight into an example. A container holds three gases, oxygen, carbon dioxide, and helium. The partial pressure of the three gases are 2, 3, and 4 atm respectively. What's the total pressure of the container? Well, so in this case, we're given the partial pressure of each of the gases. We're given the fact that pressure of the O2 is equal to 2 atm. The pressure of CO2 equals 3 atm, and the pressure of the last gas, helium, is equal to 4 atm. So we're given the individual pressure of each of the gases, and we're asked to determine the total pressure. Well, if we have the individuals and we want to figure out the total, all we do is add these together. So 2 plus 3 is 5, plus 4 is 9. And that means the total pressure, P total, is equal to 9 atm. In this next problem, we're given that a mixture of 2 moles of H2, 3 moles of NH3, 4 moles of CO2, and 5 moles of N2 exerts a total pressure of 800 torrs. What is the partial pressure of each of the gases? So in this case, we're given the total pressure of the mixture and the moles of each of the gases, and we have to determine the pressure of each of the individual gases. I drew a picture out. We have a container with a mixture of different gases. Each of the dots represent the moles. So we have 2 moles of H2. You see there's 2 dots of orange representing H2. And then we have to figure out the partial pressure. So to do this, we're going to use the equation. Let's say if we want to figure out the partial pressure of a particular gas, H2, then that's just going to equal the mole fraction of H2 times the total pressure. And mole fraction, well, that is going to equal the moles of the H2 divided by the total moles of the in the mixture. So let's figure out how many total moles we have. We have 2 plus 3, that's 5, plus 4, which is 9, and then plus 5, which is 14. So we have 14 total moles. That means the pressure of H2 is going to equal the moles of H2, 2 divided by the total moles, which we just calculated to be 14, and this times that by the total pressure of 800 torrs. So we'll just do 2 divided by 14 times 800 in the calculator, and that will give us 114 torrs as the partial pressure of H2. All right, now let's calculate the partial pressure of the next gas, which is NH3. The partial pressure of NH3 will equal the moles of NH3. We have 3 moles of that, divided by the total moles of the gas, 14, times the total pressure, 800, 171 torrs. And then we just repeat the process for the remaining gas. So I'm just going to skip over this part. I'm going to write it out and then we'll go over it. So to figure out the pressure of the remaining gases, CO2 and N2, we just do the same process. We take the moles of the individual gases divided by the total. The total is the same in each cases, times the total pressure. So for the CO2, 4 divided by the 14 moles times 800, and then for N2, it'll be 5 moles of N2 divided by the total moles, 14 times 800. And then these are the individual partial pressure of each of the gases, and if we add all these together, it'll add up to the total pressure, 800 torrs. So that's the second type of problem where you're either given the grams or the moles of each of the gases and the total pressure, and you have to solve for the partial pressure. So if you're given grams here, you would just convert all the grams to moles, and then you would just use the formula. The partial pressure of a particular gas is equal to the mole fraction of the gas times the total pressure. So that's technique number 2. In this next problem, we're given that 3 moles of N2, 4 moles of O2 are placed in a container of 35 liters at 25 degrees Celsius, and what's the pressure of the resulting mixture of the gas? Essentially, this is just asking us, what's the total pressure here? We are given the moles of the gases, the N. We're also given the volume of the gases and the temperature of the gas, and they're asking us for the pressure of the gas. Whenever we have P, V, N, and T, then that means we're just going to be using the ideal gas law. And since we're trying to figure out the total pressure, we should start by figuring out the total moles of the gas. That's going to be 3 moles plus 4 moles is 7 moles. Then once we have the moles, we can just use PV equals nRT, the ideal gas law, to solve for the pressure. So to solve for pressure, we just divide both sides by volume. So we'll just move the volume over to the other side. The pressure is equal to moles times the gas constant times temperature divided by volume. Now let's substitute the numbers in. The moles is 7. R is ideal gas constant, 0.08206. Temperature is 25 degrees Celsius, but we have to convert that to Kelvin, so we just add 273 to that, and that becomes 298 degrees Kelvin. And then we would divide that by the volume in liters, and that's 35 liters. And then that gives us 4.89 atm as the total pressure. Now, if you wanted to figure out the individual pressure of each of the gases, there's two ways we can do it. We can do what we did in the previous problem. So now that we have the total moles and the total pressure, let's say we wanted to figure out the partial pressure of N2. We would just use the mole fraction, 3 moles of N2 divided by a total of 7 moles times the total pressure, 4.89 atm, which comes out to be 2.10 atm. And then to solve for the partial pressure of O2, we can just take the total pressure, 4.89, and subtract the pressure of the N2, 2.79 atm. That's one way we can figure out the partial pressure of each of the gases. Or the other way we can do it is just use the ideal gas law, but only use the pressure, only use the moles of the particular gas. For example, if we were trying to figure out the partial pressure of N2, we would let's just take this right here, and we will only use the moles of N2. So we would just use 3 moles of N2 instead of the total 7 moles. By just using the moles of N2, we'll get the pressure of N2. And then that comes out to be 2.10 atm as well. That's how you would do partial pressure problems.
If you want to learn how to ace chemistry, if you want to learn what's the best way to study for this class, if you want to learn some neat tricks and tips to take into your exam and do better on them, then you should head over to my website and get this free guide, 12 Secrets to Acing Chemistry. You can head over to www.conquerchemistry.com/chemsecrets. I'm going to include a link in the description below. Check it out. I think it's really going to help you, and you're gonna like it. Until next time, keep working hard and continue the good work.